Have you ever wondered how does Netflix keep your personal continue watching list separate from your siblings or your friends within the same exact account? It is entirely because of database relations. Your profile ID is the primary key which is referenced by watch history table as a foreign key. And how do you ensure that if profile ID is deleted from the main table, so watch history should also be deleted of that profile ID? Today you will learn all these concepts in detail with hands-on. Hello everyone, welcome back to my YouTube channel, the Code Brat. In our last video, we talked about some basic concepts of DDL. But in this video, we will deep dive into the DDL concepts of different types of keys, relationships, and constraints. So let's get started. Till now, we have created table till movies, and now we will create table profiles. So what is special about this table profile? This table profile is a child table that will inherit some property from the parent table. And what do I mean by this? So let's create this table first. Create table, then table name. Table name is profile. So complete name will be app.profile, schema.profile, then bracket open, bracket close. And then we have this profile ID. This is the column name. Since it is an ID, it should be int, and it is a primary key. Primary key. Now next column is user ID. And if you notice here, user ID is the foreign key. I will come to this foreign key later. First, I will just create this column name here, and then this column is profile name, and profile name should not be null. So profile name will be varchar 100, and then it should not be null. So I need to write the constraint or check not null. And the last column is kid profile, whether this profile belongs to a kid or not. So by default it should be false. So since it is just true and false value, I will keep it as boolean, and then by default it should be false. Correct? Yeah. Now this user ID of this table app.profiles should come from the parent table. And what is the parent table? Parent table is users table. So if you see here in users table, this was the user table. Here also we have this user ID. So that value in that profile table should come from this users table and from this particular column, user ID, right? So what will be the syntax here? After comma, foreign key, then foreign key on which column? Foreign key on user ID column. This user ID column is from profiles table, right? So this particular thing is from profiles table. And here, do not confuse this particular name with that parent ID name, parent table name. So this name can be anything. This doesn't has to match with the parent column. So here I can write it as user ID, maybe profile user ID. Profile user ID. I'm just writing this to show you that this doesn't have to be match with the parent table. Okay, foreign key of this column, then references, which table? References users table, and on which column? The user ID column. And this user ID column is from the parent table, this column, right? And then there is one more constraint, two more constraint that we need to put here: delete and update. So what does it mean? If we put delete restrict, then if we suppose we do not want to delete something accidentally in the child table or in parent table, so accidental deletion of parent must be blocked, right? So for that we need to write on delete restrict, and then on update cascade. And what does this update cascade means? So whenever uh, we update the parent table, the child table should automatically get updated. So this will do that task on update cascade, and this will restrict the deletion of the parent value. Understood? Let's create this table now. Now this table is created. Let me explain this again so that you will not have any doubt after this video. So when we are referencing any particular column of this child table from that particular column from parent table, we write this particular syntax: foreign key, and then this column name of child table, then references, table name of the parent table, and then the column name in the parent table. And then if we do not want a parent value to be deleted, we write here on delete restrict. And if we want that someone updates the parent table, it should also get updated here as well, but only for this uh, profile user ID, not for all the columns. For whatever is being referenced, only that column. Understood? Okay, let's move on to the next table. Next table is subscription table, and this also belongs to this app schema. And there are certain rules, and there are certain rules on foreign keys as well. So let's create this table again. Table name is subscription. Create table app.subscription. The first column name is subscription ID, which is a primary key. Column name, it should be int, and then primary key. And the next column is user ID. It should also be int, but there should be the foreign key, as well as this plan ID should be foreign key. So this means we can have multiple foreign keys in one table, but we can have only one primary key in a table. We cannot have multiple primary keys in a table. So user ID is int, and this will be foreign key that we will write it later. And then this plan ID is also a foreign key that we will write later. It should be int. And then status should be by default free, and this free is a text. So status would be text, that means varchar 100, and then by default it should be free. We want to give free subscription to everyone by default. So default free, comma, and then next is start date, and start date is current timestamp by default. Since it is a timestamp, we need to give data type as timestamp. Start date, data type is timestamp, and then by default it should be current timestamp. So for current timestamp we have this current timestamp inbuilt function, and then for end date, data type is date. This end date is data type date, not timestamp. So we will give data type as date. That's it. And now what we need to do, we need to create this user ID and this plan ID as foreign key, which will reference the parent table. And what is the parent table? This user ID will come from the user's parent table, and this plan ID will come from plan's parent table. So let's do that. Foreign key on which table, and I mean which column? User ID column. Keep in mind that this user ID column of this subscription table doesn't need to match with the parent column. So use foreign key user ID uh, references which table? References app.users table and on user ID column. Okay, references this, and there are certain rules. And what are the rules? On delete restrict and on update cascade. So this means by writing this particular piece, it would ensure that we cannot delete a parent value without deleting the child. So I will write this on delete restrict, and then on delete cascade, on update cascade. And what does this mean, update cascade? That if parent value is updated, then it will automatically gets updated here as well. So this foreign key is done, and it's time for the next foreign key. Foreign key, then plan ID, references which table? App.plans, and on which column? Plan ID column. And this plan ID column is the name that is there in the app.plans table, that is the parent table. Okay, now it has a reference, and now we need to add the constraint. And what is the constraint? On delete restrict. So here we are giving only one constraint, on delete restrict, so that we cannot delete any value in the parent table directly without deleting the child value. On delete restrict, that's it. Now let's create this table. Line 8 user ID. Okay, yes, table is created. So these are the silly syntax error that you need to keep in mind. Now next is table is watch history, and watch history belongs to this particular analytics schema, not app schema, because I told earlier that we want to keep history and then analytics data into analytics space or analytics schema. So let's create this table as well. Create table and table name, bracket open, bracket close, and then the column name, which is watch ID, and it should be a primary key, int, and then primary key. And the next column is user ID, and user ID is a foreign key which should come from users table. So user ID int, and then movie ID. Movie ID should also be a foreign key which should come from movies table. Movie ID int, and then watched at, and watched at should be current timestamp by default. So watched at timestamp, and by default it should be current timestamp. And the last is end date. End date is not a timestamp, it's a date column. So Data type would be date. This is done, and now it's time for foreign key. So foreign key, uh, user ID, bracket open, bracket close, user ID, and this user ID is the column in this watch history table, which will references this app.users table, and on delete. Okay, here there's a new concept: on delete set null and on update cascade. So what does it mean? On delete set null. So here we are, earlier what we used to do here it was on delete restrict. So it was restricted that we cannot delete the parent value without deleting the child value, right? But here there is no such restriction. We can delete the parent value, but when we delete the parent value, the value inside this particular watch history table, that is the child table of user ID column, should automatically be null. So when parent column value of the parent column is deleted, then this child column should be set as null. So that's why we have written on delete set null. Understood? On delete set null, and then on update cascade. So whenever parent value is deleted, parent column is updated, uh, child column will also be updated. Cascade. Here comma should not be there, here comma will be there because we need to write another foreign key. Then the next foreign key is movie ID. Which will references movies table on movies ID column, right? And here we have on delete restrict. Here we do not have delete cascade, set null. Here we have on delete restrict, so that we cannot delete the parent without deleting child. On delete restrict. This is done. See here, we have written why we are doing this. So user ID deletion, setting user ID to null if the reference user is deleted, and for updating user ID automatically if the reference user ID is changed. Same goes for movie ID deletion. So blocking the deletion of a movie if it is referenced here, and movie ID update, blocking update to a movie ID. Correct? So let's create this table now. Table is created. Yes, table is created. I ran it twice, that's why you are seeing this error message here. And now the next table is payments table, which belongs to app schema. So let's create this table as well. Create table app.payments, and then we have payment ID. Payment ID should be int, and primary key. Next is user ID. User ID should be the foreign key, and amount would be the number. By number I meant decimal 6,2 that I have already explained in my previous video. What does it mean 6,2? And then amount, payment date is by default current timestamp. So data type would be what? It should be timestamp, and by default it should be current timestamp, right? Now it's time for referencing. So foreign key on which column? On this user ID column of payments table. References which table, app dot users table, on which column, user ID column of users table, right? And then on delete restrict, so that we cannot delete the value inside a parent table. All done. Let's create this table now. Table is created. So this second part is done. Before moving forward, I would like to explain when do we use this, like in production or in general scenarios, what do we use. So Cascade is rarely used. We do not use it in production system because there is a risk of mass deletion of data. That's why we do not use Cascade. Restrict, yes, we do use for protection of data. And then set null also we use for privacy and analytics. Set default we always use. Here I have written where, but we use it in our production system mainly for date timestamp. And then update cascade we also use for safety net. So that's all for today. We will meet in the next video where we will discuss about the indexing and then altering table or altering command, renaming commands, and some other things. If this video is useful for you, please like the video and subscribe to my channel.